speak in English and Spanish. First in Spanish. So, buenas tardes. Vamos a partir esta charla internacional del Instituto de Ecología y Biodiversidad. Tenemos el placer de tener hoy día al profesor Hugh Possingham. Profesor Hugh Possingham es profesor en la Universidad de Queensland, Australia. Él también es Chief Scientist de Accounting for Nature y de Biodiversity Council. Son dos ONG de Australia. El profesor Hugh Possingham es miembro de la Academia Nacional de Ciencias de Estados Unidos. Él también tiene más de 750 publicaciones y realmente una gran experiencia en conservación de la biodiversidad. So now I'm going to introduce you Hugh in English. So we have the pleasure to have this day the professor Hugh Possingham. Hugh Possingham is professor at the University of Queensland, Australia. He's also Chief Scientist at Biodiversity Council and Accounting for Nature. Professor Hugh has extensive experience in conserving nature, both in academic and policy realms. And he has more than 750 publications, scientific publications, and also he's a member and elected member of the Academy Science, of the National Academy of Science of America. So with that introduction, I invite you to give your talk. Hugh will be talking about if science impact policy. So it's a pleasure to have you.
Thanks a lot, Maria, and thanks to Maria and Barbara for hosting me on this trip to Chile. And Sophie for hosting me on this trip to Chile. I'm really going to tell just a few stories about the impact of science on policy. So about half a dozen stories where I'll talk about how we tried to change policy in Australia using science and how that played out through time. So you can make what you like of it. And in the end, some of it is very successful and some of it is a complete failure, just like most things. And there'll be some advice on how to proceed to have as much impact as possible. So that's what I'm going to talk about. But I'll also start like acknowledging the traditional Indigenous people of this area that we are here in Australia. We always acknowledge those people before the talk, so I'd like to acknowledge those people and reflect on the fact that, of course, they managed this land for thousands of years before Europeans arrived. So in many ways, Chile is exactly like Australia, very, very similar to Australia. It's climatically very similar, so if you put, and in many ways, politically, in a policy perspective, Australia and Chile. So there's Australia, 7 million square kilometres. Now Chile is 10 times smaller. And if you put Chile on this map and put all the climate things right, down here there's Notofagus forest in Tasmania, exactly like your Notofagus forest. And Adelaide, where I was born, is Mediterranean. So it's probably roughly like Valparaiso. And then in the middle of Australia it's desert. But our deserts are not quite as dry as yours. So our lowest rainfall would be 100 millimetres. We don't go below 100 millimetres. So basically Chile, there's my perfect map of Chile, fits there climatically in Australia. And as you can see, it's roughly 10% of the size of Australia. And as I talk to Maria and Barbara and other people, I realise that many of the environmental issues are almost exactly the same. So Australia and Chile are advanced economies, but also we're still, in some senses, although we have a good standard of living in general, much of our resources, money we make, is extractive industries. So Australia and Chile produce the most lithium in the planet. You have nickel, you have copper, we have nickel, copper, we have a lot of coal, a lot of iron ore, and then we have a lot of agriculture, and we have nice red wine. So but we don't have a lot of heavy industry, and we have some tourism. So in many ways, the economies are almost identical. The population size, who's gonna guess? Do you think Australia's got a bigger population size than Chile, or Chile a bigger population size than Australia? Who wants to go? Who's going to vote for Chile, bigger population size? Who votes for Australia, bigger population size? You're right, by not much. So Australia's about 26.5 million people. I think Chile is about 24. So again, an enormous number of similarities between the countries. The only other big difference would be your oceans are very productive, and our oceans are not productive. So in fact, Chile, I think, produces more seafood than the whole of Australia, even though we're the country in the world, I think, with the second or third biggest coastline in the planet after Canada and Russia. So there's a lot of similarities. And I think governments, I would also just say we have a right-wing government and a left-wing government. Like you, we sometimes are right and sometimes are left. And occasionally I'm going to say words like Labor, and that's the left-wing government. And then I'll say Liberal, and strangely enough, that's the right-wing government. So our right-wing government, our Conservatives, they're like the Republicans and the Democrats, if you're in the United States. And we have largely two parties that control everything, and for 5 to 10 years we have one, and then we go to the other, and we flip-flop backwards and forwards. But on average, we're probably a little bit more centrist. Both parties are very close together in the middle. So I'm going to tell these quick stories about these things, but although I'm trained as a mathematician and I'm trained as an ecologist, from a very early age I was a conservationist. So I wrote my first very angry letter to the newspaper when I was 17 years old. And I wrote it because they had bulldozed, a farmer had destroyed where I used to go bird watching with my father. So we woke up one day, drove half an hour to the bird watching site, 100 hectares of beautiful woodland and forest, not unlike your forest, and what it had been turned into a wheat field. And that made me very angry, because it was in an area, much like this area, where only 2 or 3% of the native vegetation remained, and they removed it. So I just thought that was entirely unacceptable. That block of scrub had 100 species of woodland bird, 200 species of plant, and had just been destroyed. So I suppose I've been an activist, and I've worked for not-for-profits, and I've worked on campaigns, probably done 2,000 to 3,000 media interviews in my life, on average 1 a week or 2 a week, every week since the age of 20, talking about conservation issues and biodiversity issues all that period of time. And I have been very privileged to be enabled to talk to a lot of politicians. So because I became a full professor and a chair of the department at the age of 32, I got access to politicians at a federal and state level. And the only other big difference, Australia's divided into states, and so, for example, this is Western Australia. The state around New South Wales is, Sydney is New South Wales. This is Queensland, where I live now, Victoria. So it's divided into states, and below that there's local government. So we have 3 levels of government, and I think you largely have 2 levels of government. So that makes it a little bit messy. And a lot of the environmental issues happened at a state level, and these states have different laws around the environment, where I think more of your laws are national laws. So that's good and it's bad. There's the map of Australia. We'll go back to that every now and then. These are the messages I want you to take home. These are the messages from this talk. The first one is a bit odd, and I'm going to tell a bit of a story how I did my science, and that is sometimes you end up doing work and that you think you didn't want to do. It's always useful. It's surprising how useful it is. If you want to change policy, you've got to be incredibly persistent, and you've got to be very patient. And to summarise, what often happens is you take some science to the policy people. the ministers and the government and the public servants, and you propose those changes and they ignore them entirely. And then you propose them again 2 years later. And then occasionally you just meet one public servant, or there's this little moment in time when the ministers and the senior public servants and you are all aligned, and then something happens. But that could happen any time in the next 20 years, and you never know when it's going to happen. So you just keep saying the same thing time and time again, and you hope what we say, well, I don't know if you have the phrase, when the stars align. When all the stars align, then something happens. So you can't force it, you just got to keep saying the same thing. And of course, having as many friends in government, public servants, have as many friends in politics as possible, personal friends I'm talking about, and friends in industry, the not-for-profit sector and academia. So wherever you are, you need to be able to talk to all those people. And in some senses, the most important thing is quite simple, is just to be there. So if there's a chance to meet people, meet them. If there's a chance to be on a committee, if somebody says, would you like to be on this advisory committee for local government about natural preserve, just say yes. So I say, I currently sit on 32 boards and committees outside my 3 jobs. 32. So I just keep turning up as much as possible. So they're the messages, if you want something done, to be patient. I know it's hard to be patient. There's the map of Australia. See how accurate my map of Australia is? Where did I go wrong? That's not bad. I need to work on this bit here, I think. Okay, these are the stories that I'm going to tell. The first one is around forestry. So I know you have a lot of forestry in the southern third of Chile. We also, in a way, don't have a huge amount of forestry. Most of our forests, 70%, all this is a desert, right? So our forests, the forests are there, and the harvestable forests are like that. Not big. So this is forests. They're all eucalypt forests. We have 800 species of eucalypt, and we've given you some of those eucalypts. Does anybody want to thank me for your eucalypts? I think most of what I see is Tasmanian blue gum or Eucalyptus globulus, but we have hundreds, and we harvest hundreds of species of eucalypts. And in the 1990s, there was a lot of contention around forests, and so we had green groups. They would tie themselves to trees. This is 30 years ago. They would make platforms in the big trees. They would blockade the loggers and try and stop forestry in native forests. These are native forests, not plantations. And that went on, and eventually the federal government intervened, and these are all state forests. So every state had forests that was allowed to forest. So here, down here is the tallest flowering tree in the world, the mountain ash tree. Very, very productive. They grow at 1.5 metres per year in high rainfall areas. So those state forests were controlled by the states, and the federal government stepped in and said, unless you sort this out, we will stop you exporting your wood. So a lot of the wood was chipped, turned into chips and turned into paper, which is a pretty annoying thing to do. Imagine a 90-metre high tree, and it's turned into paper, newspaper, packaging. So there was lots of fights about it. The federal government stepped in, and then they asked the question, we're going to set up a proper reserve system, and this is around a period of time when Australia was very committed to building representative reserve systems, and we had people like Bob Pressey, who died last year, Chris Margules, who's still alive, and they had developed these systems whereby you should, say, protect at least 20 or 30% of every different kind of forest. So all these forests were mapped, and there were hundreds of different forest types, and the forest industry had to protect a representative sample of every kind of forest. So that was very successful. So that was part of the process. But the thing that they didn't know was how much forest is enough. If you're going to save enough forest for a koala or a powerful owl, how much do you need? I mean, is 10% enough? Is 10% enough? Is always the question. A lot of our most threatened species are marsupials. You have a couple of marsupials, and the most famous one was leadbeater's possum. Leadbeater's possum. And David Lindenmayer, who I worked with a lot, and it just lived in this area here, in the most productive of these forests. And so we did a lot of work, and we did a lot of population viability analysis on this possum to work out, could you log some of the forests and still have a viable population of leadbeater's possum? This is very similar to what was happening on in the United States at the same time in Oregon and Northern California and Washington with spotted owls. Have anybody here heard of northern spotted owls? That was a huge controversy, and all of the northwestern forests of the United States were put under controls under their endangered species legislation, whereby they had to protect a certain number of northern spotted owls. But then the question still is how many? And in fact, that's where the whole field of population viability analysis comes from. The question is, do I need 200 pairs of northern spotted owls? Do I need 2,000 pairs of northern spotted owls? How many leadbeater's possums do I need? Do I need 1,000 female leadbeater's possums? Is that enough? What is enough? What is enough? Does anybody know what's enough? It's one of the biggest questions in ecology, right? How many individuals of a species do you need to have to be sure it will persist for a reasonable amount of time? Nobody's answered the question. We've been working on that since the first questions were first asked in the 1970s. Michael Soule, people like that, Barry Noon. We've been working for 50 years. We have no answer. But we generally think that you need usually at least about 1 to 5,000 adult females for a viable population, which is a lot. So we can run these population models, and we came up with rules to try and work out how much of the forest should be saved. Because in most of conservation planning, people just say 20%. So you know now the Convention on Biological Diversity, they've said we should conserve 30% of everything. Why 30%? Why 30%? Does anybody know why we decided 30%? Why not 29? It used to be 17, wasn't it? We had to get 17% of every ecosystem type, and now we've got to get 30. Who decided that? Where's the science behind that? Where is the science behind that? There is no science behind that. All it is, it's bigger than 17. Generally, after you get to 30, you don't have a lot of fragmentation effects. But for some species, 30 won't be enough. For most species, it probably will be enough. Most species, it will be enough. So population viability analysis is the only way to answer that question. And that involves building very big computer models of population dynamics, and you run them thousands and thousands of times, and you impose different management, different kinds of forestry, different kinds of reserves, different sorts of logging. For example, you can chop the trees down when they're 30 or 40 or 50, so that will change the viability of the population. So we run all those models. That's what David Lindenmayer and I did. And when we made proposals, and we did help them build a reserve system in this area. So that was somewhat successful. And in fact, a bit like Chile, we have a lot of fires. And so, in fact, the biggest question was, how big should the reserves be? How big? So if you have an area, an area of forest about like 2 kilometres or 10 kilometres by 10 kilometres, how much of this should we conserve? The question then is, do we conserve it all in one big area like this, or do we conserve it in lots of little areas like this? So, which is a classic old question in ecology. It's called the single large or several small question that you would have been taught probably in conservation biology. Should you have one place where there's no fragmentation problems, or you should have lots of little places where you don't get destroyed by a single catastrophe, remembering that, of course, fires come through these systems and they destroy the forest. And in the end, we came up with a rule based on lots and lots of models, and we said 100 or 200 hectares was the best size for reserve. That contains about 20 individual females, and that was good. So we did make some recommendations, worked. But then when we tried to deploy, it took us 2 or 3 years to do all that work on leadbeater's possum. And in these forests, there are 600 different species of vertebrate. There'd be 100 species of mammal, there'd be 300 species of bird. It takes you 3 years to understand one species. So in the end, population viability analysis, I don't know how often that's been done in Chile for particular species in terms of the viability of species. It's a really good tool. It works well in the United States because there's more ecologists than species, right? The United States is the size of Australia, no bigger, and they have 20 times as many ecologists as we do, and we have more species. And Chile has an enormous number of species, but you don't have hundreds of population modelers who can write computer code and look at the viability of every single species you have in the country. Reptiles, plants, birds. So in the end, it's a good tool, but you can't do it everywhere. You just can't do you can do it in Europe, and you can do it in Canada, you can do it in the United States, but Colombia, South Africa, Australia, it's impossible. Chile, it's impossible. So during that process, however, and we had some success with population viability analysis. There was some software that helped you build protected areas, and that was built by Bob Pressey and Chris Margills, and that software helped you protect 20 or 20% of every type of habitat. So, but it never clumped habitat together. So in fact, it just grabbed tiny bits, and it was a highly fragmented reserve system. So I had a PhD student, and his name was Ian Ball, and he came to me to do his PhD, and he was very good at mathematics and very good at programming, but he didn't have a PhD scholarship. He had no money because he'd followed his wife, who had a scholarship. This is 1993. He followed his wife, he had no scholarship, he started a PhD, but he didn't have any money. So the government was trying to build new software that would help them do the spatial planning for this area, so that then you built these reserve systems. And what is a good reserve system? You represent all the habitats, you have viable populations of every species, it's well connected and compact, and it also minimises the impact on industry, so you don't take very profitable forests away from people. So that's what MarkSand does. So we built that software, and we built it solely because Ian couldn't get a scholarship, so we need to get him consulting work to be paid by the government, which he didn't really want to do. So I suppose it gets back to point number one. Sometimes you're in a difficult situation and you have to do things you didn't really want to do, and half of his PhD was developing the tool MarkSand for this forestry process. And that tool now, and Jennifer has been the champion of that tool for that now produces probably half of the world's protected area systems and the entire planet. Half of a PhD. It was used to rezone the Brazilian Amazon. It's used by all developed local governments in South Africa. It built the protected area systems around the United Kingdom. The Nature Conservancy globally has used MarkSand to do all their spatial planning. It literally has changed 10% of the surface of the planet because one person didn't have enough money to do a PhD. So sometimes adversity is a friend, right? Sometimes adversity is a friend, and doing things you didn't really want to do can be very, very valuable. Well, we built that tool around 94, 95. A few people started to use it. The Nature Conservancy started to use it in the United States. About 1998, we had a reasonable piece of software. And then, in fact, at that point in time, it was called SpecSan. So it's called SpecSan, S-P-E-X-A-N. So that was what the software was called. It wasn't very sophisticated, just ran on a PC with DOS and things that you probably don't know anything about because you don't use DOS anymore. It's very primitive software. The Great Barrier Reef Marine Park Authority came to us and said, we're going to rezone the entire Great Barrier Reef. So the entire Great Barrier Reef is this. This is, I mean, some people say it's one of the 8 wonders of the world. It's 5,000 coral reefs, 5,000 coral reefs, covering an area the size of Italy. It's the size of Italy. So it's gigantic. And in fact, it generates for the Australian economy around about $10 billion a year of tourism. So it's very important. In 1998, only 4% was protected from fishing. So the Great Barrier Reef was created to stop it being mined. In the 1970s, people would go into these coral reefs and they would blow them up to get limestone to put on the soil. So if you have acidic soil, you can blow up the reef and you gather all the dead coral and you put it on a piece of agricultural land, which is sort of, that was somewhat obnoxious perspective in terms of agricultural practice. So they wanted to stop all that. People had discovered oil there, so they didn't want oil wells there. So they came to us and said, can you help us with a spatial plan for the Great Barrier Reef? Because at that time, as I say, only 5% was protected. So we said yes, and they said, can you use this tool that you have from forestry that's called SpecSan, which was used to protect forests? And they said, but the marine world is entirely different from the terrestrial world, so you need to rebuild the software. So I said, no, the marine world is not different from the terrestrial world. The fundamental principles of conservation planning are exactly the same. Protect a representative sample of every habitat type. In this case, they wanted 20%. Make sure it's well connected and try and do it in a way that doesn't ignore, in this case, just does not annoy the fishing industry. Because there's some places they fish a lot, and if you protect them, they will go to the politicians and they'll say, we're not going to have this protected area system. So what we did was we changed the software a little bit and we renamed it and we put the letters MAR in front. So then the marine people thought it was all about marine protected areas. So it was sort of advertising. It's like Coca-Cola, you know. It's no more than deception. Because basically, one of the other things I've learned is marine people and freshwater people and terrestrial people, they all think they're incredibly special. Does anybody here think they're mainly a terrestrial ecologist? Freshwater? Marine? None? All of the above? You shouldn't be any of them because in many ways they're all really just ecology, right? They're slightly different, but they're all basically ecology. And so this software worked and it was very successful. By 2004, on July the 1st, they rezoned the Great Barrier Reef. So this is 20 years ago, and they built the first comprehensive representative reserve system in the planet. The first time it was done properly. Connected, representative, minimising the impact on industry. So that was wonderful. We thought, that's great, that's very successful. And then everybody around the world started using MarkSan. Everybody started using it for all these activities on all the continents. Probably the least, it's less use in Europe. And in fact, Jennifer and I came here in 2013 and we trained people in the use of MarkSan and spatial planning. And it's been used in Chile. I suppose it somewhat informed some of the protected area expansion. So you think, well, this is great. We can just do this everywhere, right? So science does inform policy, and mathematicians and scientists, we really are useful. Around about 2004, 5 or 6, the party that was in, which was actually the right-wing party, so this all happened under a right-wing government. Robert Hill was a Minister for the Environment. He was a right-wing minister, and he did all this rezoning. And then he said, well, let's do it for the whole of Australia. All the marine areas, which is out to 200 kilometres. This is an area the size of Australia. It's 8 or 9 million square kilometres. It's bigger than Europe. Let's do the whole thing. But the people they put in charge of it just decided science was useless. Systematic planning was a waste of space. We're never going to use mark sand. We're just going to grab random bits of the ocean. And that's what they did. They grabbed bits all over the place. And they got to around about 15 to 20%. But they ignored the habitat layers. They mainly put the protected areas where people didn't want to go. So, for example, in this part of Australia, the Northwest Shelf, it's a huge area. This is the size of France, for example. And if you look back on this map, you can see this area here I'm talking about. They rezoned that. They ended up protecting 10%. And do you know what 10% they protected? They protected this. So this is what's called the abyssal plain. Abyssal plain, it's 3,000 metres deep. There's the shelf. You can see the shelf. And they just protected this, and they protected almost none of that. Where is all the biodiversity? How much lives down at 3,000 metres? Well, a few interesting things live down at 3,000 metres, but not a lot. So the question then is, they said, well, we protected 10% of this region, 10%. We protected this 10% and a few bits here and there, but basically none of the shelf. Why do you think they did that? Why did they do that? What's the reason for not obeying any of the rules of conservation planning, having successfully done it? Oil, gas, and a bit of fishing, mainly oil and gas. So we thought that marine conservation is all about getting conservation outcomes against fishing, but in fact it isn't, because in the world of power there's oil and gas and coal, and then there's agriculture, then there's fishing, and then there's us, right? Then there's biodiversity. We're at the bottom, although hopefully we're moving up. But bottom line is they did not want to have any marine protected areas over anything where they could possibly produce any gas, because Australia has a lot of gas. We produce as much fossil fuels of any country in the planet, second to Saudi Arabia. That's gas and coal. We don't have a lot of oil, we have lots of gas and coal. So, big success, and then a big failure. It doesn't matter how much scientists, how many people talk to the politicians. Robert Hill was then out of office. We changed to a Labor government, and they still did a terrible job. And they ended up with the reserve system that just represented places that nobody else wanted, which is generally the reserve systems you get. Deserts, mountains, places that are too wet. All the places that nobody else wants. So I suppose sometimes it goes well, sometimes it goes badly. For it to go well, you need senior bureaucrats and public servants and politicians to believe what you're saying. And you actually almost have to have you have to know them by name, you have to have a personal relationship with them. So science never wins on its own, unfortunately. Science only wins when you're there pushing it along. So, tick, cross. Okay, one all. Around about the same time, 1998, our federal government was having discussions about, we had a new piece of biodiversity legislation called the EPBC Act. It's like the US Endangered Species Act. Do you have an equivalent Endangered Species Act in Chile that... Right. So our Endangered Species Act says if somebody's making the development and there's a listed endangered species, of which Australia has 2,000 listed endangered species, then the federal government can say no. They said no, the development's not going to happen. No, you can't put that dam in, you can't put the road in, you can't clear that for agriculture. So it's a potentially strong piece of legislation, 2,000 species on it. And those 2,000 species, they also used to spend money. They used to spend $10, $20 million a year recovering those species, again, like the United States. And I went to a meeting and they were talking about which are the most important species. Of 2,000 species, which ones were the ones we should spend money on? So what should we spend money on? Because they decided we could only probably spend money on about 200. What should we do? What's the most important species to spend money on? Species that are cute, that you can cuddle. Endemic species. Keystone species. Any other? What would you spend money on? What do you spend money on in Chile in terms of threatened species? Emblematic species, like your little deer. Right. So what they generally did was they looked at the list of 2,000 and they took the critically endangered, so those lists says critically endangered, there's endangered, and then there's vulnerable, and then there's near threatened. So these are the IUCN categories. Critically endangered species are so endangered, you basically think they're going to go in the next 20 or 30 years. There's like 50 of them left, or they're in 10 square kilometres. So they just go to the critically endangered ones, and then they spend money on them, and then there might be a couple of cute ones further down the list that they pick out, and that's it, because then they run out of money. And I said, well, if I had $50 million a year to spend on species, what if some species were cheaper to save? What if there were some plants? Barbara likes plants. And you can generally save an entire species of plant for $10,000 US. $10,000 US, you can save it. You protect its habitat, might be just a square kilometre, you get some seeds, you grow them up, you protect that 1 square kilometre, you might have to fence them off from cows and goats or other things. 10,000, how much do you think it costs to save some threatened species? $10 million. The Californian condor, like your Andean condor, they would have spent $50 million on that one species. So should you save the Californian condor for $50 million? How many plants can I save for $50 million? At least 1,000, right? 50 million, 50,000. $50,000, that's an expensive plant. What do you think? Would you save 1,000 species of plant, or would you save the Andean condor? 1,000, that's every endemic plant in Chile, probably 1,000 species of plant, maybe not 2,000. Would you save 1,000 species of plant, or would you save the Andean condor? Anyway, I go for the plants. Yeah, and the Andean condor, they're just a gigantic turkey vulture, aren't they? Or a gigantic black vulture. So I said you should include money, and you should spend money on the cheap species and the species that are easy to save and the species that are most likely to save. So I had other factors in there. How easy is it to save and how cheap is it to save? And they said, you can't do that. That's triage. So a good French word, does that translate, triage? Yeah. Triage. We're prioritising, and we're going to pick, so we save the most species. And what did you think they said? Hugh, you're a mathematician and an ecologist, you are stupid. We're never going to do that. We've got to save everything, so we'll save these critically endangered ones. And while we're saving the critically endangered ones, of course, all the endangered ones are becoming critically endangered, and the vulnerable ones are becoming endangered, and the problem just gets worse and worse and worse. So anyway, they told me to go away. So what does a scientist do when they're told to go away? They write lots of papers. So we wrote papers, and then finally we wrote enough papers that New Zealand, funny little group of islands over here, about the size of Chile, I think, roughly, and probably just a wet version of Chile, New Zealand, a cold, wet version of Chile. They said, we have a problem too. They had 2,000 endangered species, and the economy of New Zealand is much smaller than the economy of Australia. They were working on about 130. They were doing well. They actually have a very strong conservation ethic in New Zealand, very successful conservation scientists. They could save about 130 what they were doing, and they said, we want to use your method to prioritise them. So we've developed the method. It's really just cost effectiveness. It's number of species saved times probability of success of saving them divided by the cost of saving them. So that's cost effectiveness. It's how you go shopping. You shop using cost effectiveness. If you go into a shop and there's a kilogram of rice for 1,000 pesos, and then there's 3 kilograms of rice for 2,000 pesos, what do? If you like rice, you buy the 3 kilograms for 2,000 pesos. You don't buy the 1 kilogram for 1,000 pesos. So every person in the planet understands benefit divided by cost, right? We all understand it. It's just common sense. People have done that calculation in their head for 2,000 years, ever since we invented currency. For 2,500 years we've been doing those calculations. Governments can't do that calculation. They don't know how to do cost effectiveness. But New Zealand decided they would. So they did it. They adopted it. I had a student called Liana Joseph. She wrote a protocol and a method. And in that case we had a senior public servant called Richard Maloney who drove the process through the bureaucracy, through the bureaucrats and through the politicians. And then they could actually save 400 species. They could save 2.5 times as many species with the same amount of money. And then New South Wales did the same thing. New South Wales is this state here, the state that has Sydney in it. This is the most prosperous state in Australia, 10 million people. And they adopted the approach. And often when I talked about this approach, and I gave talk after talk, I still give talks about this, people would say, but if you use economics and cost effectiveness, it'll be an excuse for the government to spend less money. Because they say, well, you don't have to save everything, we'll just pick the cheap ones and we'll spend less money. Well, in fact, what happened in New South Wales, we went to the minister. Many ministers are economists. Politicians are often economists and lawyers. And we gave them this logical plan and we said, if we use cost effectiveness, we can save many more species. And they gave us more money. They gave us more money. They gave New South Wales $20 million a year more for threatened species, $20 million a year more for threatened species, because they had a business plan. So one thing I would say to you as conservationists is the most important thing is don't go to governments keeping on saying, well, we should go to governments, spend more, spend more. Yes, spend more on conservation. How often does that work? Not often. But if you say, give us this money you're giving us, we're going to rearrange it so we can do more with that money. Can you now give us more? You will get more money. You'll get more money. So you're showing that you're being fiscally responsible. You're being smart. You're being a smart accountant, a smart economist. So that was very successful. Does every country in the world do this? No. So for 5 or 6 years, finally got New Zealand on board, then New South Wales. The state I live in, Queensland here, which is the most biodiverse state in Australia, I've been talking to them for 15 years about this, and they're only just starting to do it. It took me 15 years. They would create these other formula for how do you prioritise species based on a whole heap of criteria that we ignore money. They just say, how cute is it? You know, is it a keystone species? And they create scoring systems. I give a whole talk about that. And basically, it's inefficient. They save less species. They save less species. So this, you know, half a tick, not one, not complete failure. Been working on this for 25 years. You know, half a tick. The United States is thinking about it. But it's interesting, people find it very offensive to consider money in decision making. And I say, well, why shouldn't conservation consider money in decision making? Do you have an infinity of money? No. So you've got to think about money. You've got to be cost effective. So one of my strongest recommendations, if you're talking to people with money, is tell them how you're using rational approaches to allocate money to decisions, because you will get more money. Now, how am I going for time? What time is it? I've lost my time. 4:55. Okay. I'll give one more example. No, that's okay. I'll give one more example. Then we can have questions if you like. But the last example I'll give is about biodiversity offsetting. Who sort of understands what biodiversity offsetting is? You familiar with biodiversity offsetting? You say compensation. So I'm going to. This is where there's a lot of money and there's a lot of jobs. So if you don't understand biodiversity offsetting. Compensation. So this is biodiversity compensation. So again, around about 2005, we were working closely with the government, and we said we're going to work on better offset calculators, so you could work out how to have a nature positive world. This is now we talk about nature positive. This is 20 years ago we were saying, how can you be nature positive and allow development? And they had an old method whereby if this is sort of some vegetation, let's say this is some matterale, and let's say this is 100 hectares, and somebody says, I'm going to destroy that, turn it into shopping malls, a mine, whatever you like. And their old method was, well, you had to protect, make it a bit bigger, 200 hectares somewhere else. So this is the same vegetation type. So these are the same vegetation types, and we will just protect 200 hectares somewhere else. What do you think of that? Well, that's a way of destroying a third of all the vegetation. So that's not nature positive. So they wanted us to come up with a calculator that actually said, well, how do you decide how to do this compensation? And most of it, of course, isn't just the area. You actually then have to add 100 hectares to this. So we would need to restore 100 hectares. Okay, restore 100 hectares of habitat. And then that's nature positive, or at least nature neutral. But this has to also apply to threatened species. So if there was some orchids here, or there was a frog, or there was a bird, then we need to do that there. Then we might have to do things in other places to do the full compensation. And what can you say about habitat restoration? Does habitat restoration always work when we do it? No. Half the time it fails. You plant the trees, they die. If you do it with seagrass or shellfish beds, if you're doing it with threatened plants, they often don't grow. So you have to have multipliers to account for probability of success. So often the rules have to be much bigger. So we made a whole spreadsheet and a system for doing offset calculations. So we had offset calculator. And it's no more complicated than a linked set of 3 Excel spreadsheets. Now the odd thing was they had done one and it made no sense. So they gave us their offset calculator. There were 3 spreadsheets. There was a blue one, an orange one, and a yellow one. And we went away, Martine Marin, Megan Evans, myself, we looked at these calculations and we thought they were all wrong. So we redid them all, but we kept their colour scheme. So we had a red, orange and blue spreadsheet, and they were all linked up. And they didn't really think we'd done much. We changed everything, but we kept the colour scheme. And they adopted that. And so that's what they use now, that offset calculator. They published it. We published the offset calculator. Other countries now use our offset calculator. And the whole idea is it's meant to deliver nature positive, and there's a whole heap of mathematics behind it. But it's not complicated mathematics. It's not complicated mathematics. It's mathematics of multiplication and divisions and other things. And probabilities of success and failure and money. So all those things were in that calculator. So what's the lesson from that is when we first started doing that work, the federal government told us, don't do it. And for 5 years they refused to give us any money to do that work, but we kept doing it. Brendan Wintle did it. We did all that work. And then suddenly they decided they need this in 3 months. And they said, can you give us a new calculator to do all biodiversity offsetting for the entire nation of Australia in 3 months, and we'll give you $20,000, which is nothing in Australia. It's nothing. And we said, yeah, we can do that, because we'd actually already done it. We'd already done it, even though they told us never to do it. So a lot of people will talk to you about how you need to work with governments. You do need to work with governments, and you have to have friends with governments. But what we did, we sat on those meetings and we worked out what they would need in the future, but they didn't think they needed it now. So the other thing that a lot of public servants suffer under is they're not allowed to think long into the future. They're not allowed to do things that will be important in 5, 10 or 15 years' time. All they can do is, the politicians say, solve this incredibly complicated problem and do it in 3 months before the next election. And then they all scramble to do it. So you've got to sit there and think, what will these municipal and federal governments, what will they need in 5 years' time or 10 years' time? And you should do that research for them now and then predict when they're going to come screaming to you, help, help, help. And then you give them that help, which is sort of annoying. But that's what you have to do. There's nothing you can do about it. So yes, I'll end on that. So sometimes it works, but you have to think a lot about what people need in the future. So I suppose this, the same is true all the time, and in the end there's failures and successes. So I could tell you another 10 stories. Maybe one of the things I think is also most important, one of our most successful outcomes was writing the Brigalow Declaration. You can Google this. They were clearing habitat in Queensland at a rate of 500,000 hectares a year. 500,000 hectares a year of habitat destruction. That puts Queensland up with Brazil in terms of land clearing. I don't know how much you clear here every year, how much you destroy. And all we did here was we wrote a statement about the impact of land clearing on biodiversity, on carbon, on water, on marine ecosystems and aquatic ecosystems. It was 2 pages long and it had 20 references. And it said land clearing is not good for the economy, it's not good for the environment, and it's not good for society. We gave it to the Premier of this state, that statement, and we gave it to the Prime Minister of the government, and within a month he stopped land clearing. And land clearing went from 500,000 hectares a year to 50,000 hectares a year. 50,000 hectares a year. That single statement by scientists, we had 500 people sign it, that I wrote, that single statement reduced Australia's greenhouse gas emissions by 5%. It's the equivalent of taking half the cars off the road. And when I wondered, well, why didn't you do this before? And I spoke to the politicians, they said, we didn't know the science. The science which had been known for 20 years. I mean, who doesn't know that habitat destruction causes erosion? Who doesn't know that habitat destruction releases carbon dioxide in the atmosphere? Who doesn't know that habitat destruction destroys biodiversity? Well, apparently most people don't. So the other important thing is you don't have to do anything interesting and you don't have to do anything new. You just have to take what 95% of or 99% of scientists know, put it in a format that is easy to understand, get 100, 200 of the most prominent scientists in the country to sign it, and sometimes you get a dramatic outcome. That said, the government changed 4 years later and they reversed all the laws and the land clearing went up again. But that's another story. So, and then we had to fight the fight again. And I'm literally, having written my first letter in 1978, I wrote my first letter to the government complaining about land clearing. I'm still writing to governments complaining about land clearing. Still writing, I just wrote one to the Premier of the state saying we had a committee, we provided them with solutions, we wrote a report, we spent 6 months on it. When are you going to do something? So you just got to keep writing the letters to the politicians, put it in plain English. And don't send an email. Get out a pen. Does anybody know what a pen is? There's a pen, you write with them. And write a letter on a piece of paper and you put it in an envelope and you post it. It has more impact than sending them emails, because emails are just bzzzt. If you give them a handwritten letter, they're very impressed. Or you could type it on a typewriter. I don't know. Do they exist? You can't. Got to find a typewriter. And the final thing, other than all those lessons, is you need lots of friends. And I have thousands of friends. I think it's now 1,300 co-authors. And then I have lots of friends in government. David Lindenmeyer did work on the population viability analysis. Mark Sand, Jennifer, who's here, is a friend and does spatial planning and now continually improves Mark Sand, so it's even more useful all around the world for marine spatial planning. Martine Marin did all the offsetting work. She's probably the most famous person on biodiversity offsetting in the world. Mick McCarthy, Brendan Wintle, all modellers, all people who are quantitative ecologists delivering tools to government to make a difference. But as I say, sometimes it works and sometimes it doesn't. But if you don't try, nothing will happen.
You need a bullet for deception again.
Oh, deception.
The colour scheme.
Oh, deception. Branding and deception, yeah. Well, yeah. So yes, do what has to be done to get an outcome you need. Sometimes, yeah, it's not science that's useful. It's communication as much as anything else. Thank you very much. That's right. Thanks. Persistence. Thanks. Thank you. I'm happy to take questions. Oh.
Questions?
No. You can do them in Spanish if you like.
In Spanish and I can translate. Pueden hacerlo en español y yo lo traduzco. Yeah? So you have to do it with the microphone.
Thank you, Professor. No sé si se escucha.
Is it still working?
Yeah, it's on.
Hola, hello. Thank you, Professor Possingham. Bueno, me llamó mucho la atención el hecho de que hablara de cuántos individuos se requieren de una especie y que eso es propio de la ecología. Y creo que es muy importante tener en cuenta el impacto que podemos producir en las políticas, la incertidumbre. Creo que eso es algo que no todos los científicos ni los académicos consideran en la arena política.
Synthesizes probably. He was telling that it caught his attention to have like a number, a minimum population viable number presented to politicians.
Yeah.
No?
How, in simple, how many individuals? No. How do you think that politics of knowledge? Yeah. How do you think that politics of knowledge? Yeah. Public funding goals on science policy of a country may influence this story of success and failure. Example, in Chile, the public funding of science to research is a very competition. And the goals not always consider the impact in public policy or in other areas beyond academia. And how in Australia past this?
That makes sense. So, I mean, I think in Australia, when I started doing research, most of the research went to basic pure research, not applied research, particularly in ecology. So a lot of pure ecology. But around about mid-90s, 2000, more and more effort went in the rise of conservation biology, biodiversity conservation science. I mean, the Society for Conservation Biology in Australia is almost as big as the Ecological Society of Australia. So more and more conservation biologists, and the government actually have changed many of their funding things to talk about impact and policy and management. So they've transitioned from pure research to impact research. Now, in some areas, people get annoyed by that because, like in physics, you know, a lot of the money is now going to physics that can create unusual materials that will be developed and commercialised and make lots of money. So, you know, that's annoying and the fundamental physics loses out. In conservation, however, we've managed to convince them. For example, recently they announced the 4 national priorities in Australia, and one is biodiversity. This is priorities across all things: health, engineering, physics, chemistry. One of them is biodiversity. So they do believe it's important, and they when we now write grants, we're more successful if we tell people how the science will change policy and management. That said, getting the policy and management changed is still very, very difficult, because in people's minds, health is here, this is health, and that where 50% of all government funding goes to health, and then social security is the next biggest with 20 or 30%, and then there'll be defence and utilities, and in fact the environment only gets less than 1%. So they don't have a lot of money, but they're happy, they do support a lot of research in it.
¿La cuestión?
¿Lo puedo hacer en español? Sí, sí. Pero lento porque se me olvida. Ya. Sobre la transición ecológica, porque aquí en Chile se está trabajando para la transición ecológica justa, se le llama acá en Chile, pero ¿cómo ha funcionado esto en Australia? Si es que existe alguna estrategia, si es que existe algún plan, porque finalmente igual se habla como desde los países del sur global, que se ven un poco más afectados y quizás son más vulnerables por las amenazas del ya sea cambio climático o en general los cambios globales. Entonces, ¿cómo ha funcionado esto en Australia? Ay, no. O sea, es que creo como que en cada país se define distinto, pero quizá más como transición ecológica. Ecológica, no socioecológica.
She was asking, because in Chile we have now a program in this government about like a just transition, like a socio-ecological transition that it's right. So we're gonna, I think I was asking for the definition of the transition, of socio-ecological transition, because I think a committee is just started. So she was asking how this socio-ecological just, like more like more equal or equitative has worked. Yeah, yeah. If you have some policy similar to that.
Yeah, I mean, there's multiple dimensions to conservation issues now. There's multiple dimensions. And in Australia, clearly there's the money side. So you need to be cost effective and cheap. You need to deliver biodiversity, ecosystem services are all important. Carbon is important. But then the fifth dimension or third or fourth dimension is equity. And that is considered now, for example, we're producing a new nature positive research centre, and equity would be an outcome. So say, well, when I was working for the Nature Conservancy in the United States, they would look at all their projects and they'd rate them on 4 or 5 broad criteria, and one was equity and whether you did harm to people. So in general now, that most big conservation organisations want to make sure their conservation project improves equity, or at least doesn't make it worse. But there's plenty of examples where that hasn't worked. So, for example, one of the best ways to solve fisheries problems is you privatise a fishery, and that's happened here in Chile. They take a fishery, they privatise it, and they hand out shares, and then all the fishermen own it. They own the fishery, and therefore they look after it better because they own it. So there's no tragedy of the commons. The sad thing is you go back to those communities later and you find that the 50 fishermen who owned this fishery now is 20, and then 10 years later it's 5, because the successful ones buy out the unsuccessful ones, and then you concentrate wealth and power and you end up with inequity. So there's no doubt about it, many conservation interventions create inequity. And I think we need to pay more and more attention to make sure that you don't make things. And of course, Indigenous people can be disadvantaged. In Australia, some of our best conservation programs now, we have a lot of Indigenous rangers. So Australian Aboriginal people, they manage the properties. About 20% of Australia is now owned by Indigenous Australians, and that number keeps going up. And they have carbon farming projects, and definitely that's an improvement in equity. That said, let's be honest, since I was born, the world has become less equitable. Did they just publish a result saying the top 10 richest people in the world own as much as the bottom 2 billion? 10 people, or 100 people, I think it was 100 people, own as much as 3 billion people. It's ridiculous, right? And we're going to have the first trillionaire in 10 years' time, a trillionaire. So that means that person owns as much money as, if there's 10 billion people on the planet, a trillionaire, they own as much money as $100 for every person in the planet. They could give everybody in the planet $100. Which for some people, I mean, again, half the world is on less than $3 a day or $6 a day. So, yes, so inequity grows, and conservation movement realises that, and we don't want to, at least we don't want to make it worse by what we do. But I have to say that's a very complicated problem. Because you never know how people are. Human behaviour is very unpredictable. Modelling populations is unpredictable, but modelling human behaviour is even more unpredictable. Because if you could model human behaviour, you could make billions of dollars off the share market, couldn't you? But by definition, we're unpredictable.
Yeah. Another question? Someone has a... ¿Sí?
Me gustaría saber como un poco como te voy a decir en español lento, como el backstage cuando trabajan académicos y las comunidades. Como qué tanta relevancia ha tenido la toma de decisiones y qué opina un poco como de la ciencia ciudadana en temas de conservación.
So I'll give 2 examples. Let's say on that allocation of money to threatened species, by doing it that way, at least you're making the decisions transparent. So, and you can ask people, do they have preferences, and they could be included in the formula. So at the moment, most countries allocate funds to threatened species and nobody knows why. There's no document that explains it. They just do it, and it's usually scientists and middle-level public servants who have that power, so that, or people lobbying and pressuring. So a community who has a strong voice, they will get more money. So at least if you have a formula, mathematics is transparent, because you can't lie with mathematics. It's a formula. It's like statistics. You can't lie with statistics. So it's there, and it's transparent, it's repeatable, and also mathematics is an international language. So anybody, a Russian can understand it, as well as a Chilean or an Australian. The second thing, I suppose, with things like Marxan and spatial planning, which does affect local communities, what we've worked on now, and Jennifer's been working very hard on, is making versions of Marxan that are much easier to use. So it's up in the cloud, people can see the data layers, they can play with it themselves. It's not like 5 years ago, Marxan, you really had to have courses, you had to be good at geographic information systems, you had to have some basic maths, not a lot, but some basic maths, and then you could do spatial planning, and making a good spatial plan might take 3 months. If you were very good, 3 weeks. But now communities can pull in the protected area system to the maps, they can set targets, they can see what's going on, and it is in English, and they can make their own. We hope that in the next year or two, Indigenous communities, local communities will be able to make their own plans with Marxan. So we call it democratising Marxan. And that's part of equity. There's outcome equity. Outcome equity is how did it affect me? But then there's procedural equity, which is giving people the power to be part of a decision-making process. And that's part of equity. I mean, there's multiple dimensions to equity. We tend to think of outcome equity, what did I get? But there's also process equity, which is what you're talking about. Yeah.
Good, we're getting there, yeah. Another question from the public? Well, I have one question, because I think you talk about the nature positive framework, and we are mainly ignorant about it. We haven't adopted in Chile. So can you define what it is and how it's implemented in policy? So I don't know if it comes from IBES or...
Yeah. I mean, I think particularly the Europeans are probably ahead in this space. The idea is that every big company and every government should present not only their financial accounts and their carbon accounts, but they're going to have to present their biodiversity accounts. So that's the first. It's a task force on nature-related financial disclosures, and they would say, I'm Coca-Cola, and worth billions of dollars or trillions of dollars, and this is my impact on water quality, this is my impact on threatened species, this is how much habitat my company has destroyed, and these are all the good things I've done, and you try and quantify them. So that's the first step, is just transparency of accounting. Because you think about, we're trying to making accounting systems for nature. The accounting system for money wasn't really invented until the 1600s in Italy. So they invented accounting standards. And then we had auditors and we have financial accountants. So the financial system has all these layers. There's bankers, there's people who lend you stuff, there's auditors, there's accountants, there's financial advisors, there's all these things. And even then the financial system is very, very complicated. It has all these independent layers. It still doesn't work perfectly, does it? There's fraud, there's corruption. People, you pay too much for things, they shouldn't pay too much. There's companies that charge you too much for things. So we have to build the same system for carbon, and we've sort of half done that, but there's still corruption, there's greenwashing, there's fraud. Carbon markets aren't working perfectly. And money's simple, like it's just dollars and cents, and a peso, an Australian dollar, a British pound, you can convert them all. Money is very fungible. Carbon's very fungible. If I emit a kilogram of carbon dioxide now, it has the same impact if I emitted it anywhere else in the planet. It's one molecule, and we have a conversion factor from carbon dioxide to methane, 25, we have a conversion factor. But biodiversity, imagine the challenge of biodiversity accounting. There's 8 million species on the planet. There's thousands of vegetation types. There's ecosystem services. So we're really at the early stages of the quantification of nature. Australia does most of its biodiversity accounting through vegetation extent and condition. So we just multiply the hectares times the quality of the vegetation, and we get a credit for that. So if you have 200 hectares and you turn its quality from 50% quality to 70% quality, you get 200 times 0.2. You get 40 points. 40 points of vegetation condition improvement. So that's the simplest type of biodiversity accounting. And the idea in Nature Positive is that every company eventually, their books will say, we have benefited biodiversity every year. That's what we want. We want all the companies through all their supply chains to prove that their total actions, including their supply chains, are improving biodiversity. That's a long way away, right? And then the idea is if they don't, they'll get fined, they'll have to pay compensation, or people will stop drinking Coca-Cola. If Coca-Cola can't prove that they're improving things, we'll all drink Pepsi. I don't know. Apparently 60% of people, on blind trials, 60% of people prefer Coca-Cola to Pepsi. There you go.
I think, no one has enough, so we're going to let you go. So 3 tips to be successful is to have a mathematician, to have a easy software that it's accessible and that decision makers and the community can understand. And also we have to democratize it, what Jen is doing. That everyone use it, and spreadsheets. Something else? There's something else? To be successful? And turn out and be persistent. So we have this synthesize it. So I'm gonna give a